Alright, today we're going to learn how to solve quadratics by factoring. Factoring method is a great method to use. It doesn't always work, but it is the technique that we will use probably more often than not. So one of the questions we want to ask ourselves is, what does the graph of x squared look like? The graph of x squared is a parabola. That's the name we give it. I'll spell that for you. Parabola. When we solve a quadratic, what we're really doing is figuring out where it crosses the x-axis. And those are our solutions to the quadratic equation. As I said, factoring is the way we are learning today. There are other methods. Square rooting both sides is another method. We'll do that another day. And the quadratic formula we'll learn later is the third method. This method always works with every single problem, but it does take some time to complete. Factoring is a much more quick way of coming up with the solution. How do we do this? Well, we're going to use what's called the zero product property. And what we can ask ourselves is this question: if AB equals 0, then what do we know? I know that A or B is equal to 0. I know this because A times 0 would give me 0, or 0 times B would give me 0. So what we're going to be doing when we use the zero product property is asking, what makes this binomial 0? The answer to that is when x is 7. What makes this binomial 0? The answer to that is x equals -2. -2 plus 0, or -2 plus 2 is 0. The same as 7 minus 7. That is also 0. To solve quadratic equations using factoring, we first have to set the equation equal to 0. So let me add that word in here. Set equation equal to 0. We do that by moving all terms to one side. Watch your signs. Then you factor completely using the techniques we've been doing, looking for the GCF to make things easier. We check with the smiles, and then we're going to use the new part, the zero property, which means we're going to set each part equal to 0 and solve. Let's look at one of these examples. Here we're going to say, this is already factored, so this one's really easy to set up. We're going to say x minus 1 equals 0, or x minus 4 equals 0. When either of those two cases happen, this would be a true equation. So when I add 1 to both sides, we find out that x equals 1. This is one of my solutions. And then when I solve the other equation, I get x equals 4. So this equation actually has two solutions, 1 and 4. Let's look at a second example. This one does not have the equation set equal to 0. That's the first step we have to do. I always want my x squared to be positive. So make x squared positive. So I'm going to leave the 3x squared on the left-hand side. I'm going to move my 19 to the other side, which means I have minus 19x. And I'm going to add 20. So I have minus 19x, and I added 20 to the left-hand side. That equals 0. At this point, I need to factor 3x times x, and then I'll have a 5 and a 4, minus and minus. That creates negative 4x and negative 15x. And this equals 0. I'll finish this on the next video. Right, I was finishing up this problem. What I had done so far was I had moved everything to the left-hand side, so I did set equal to 0. I factored, checked with the smiles to make sure that I created that negative 19, which I had. Now I'm ready for my last step, which is to set each part equal to 0 using the zero product property. So when I add 4 to both sides on this equation, I get 3x equals 4. And then I'll divide by 3, which gives me 4/3. That's one of my solutions. On the other part, I have to add 5, which gives me x is 5. So my two solutions are 4/3 and 5. On the next problem, it is already set equal to 0, and it is already factored. So I can just take each part and set it equal to 0. Solving this equation, I get x is equal to negative 5. And the second equation, when I add 7 to both sides and then divide by 2, I get x is equal to 7/2. So I have the two solutions of negative 5 and 7/2. This next problem, what's different about it is I have this negative x squared. One of the things that we don't want is we don't want a negative on our x squared. So we're going to add that in there. No negative on for the x squared part. The reason for that is just makes it easier to factor. You can still factor it with a negative on the front, but it just looks different, and so people have issues with it. So what I'm going to do is I'm going to add x squared to both sides. So I'm at 0 equals the x squared. I'm always going to write the x squared part, then the x, and then the 3. So it's in that standard form. 0 equals, and then you factor. X times x is x squared. 3 times 1, I get a 3x and a 1x. Checking my smiles, I need a negative 4, so I need a negative and a negative. Now the last step is to take each part and set it equal to 0 and solve the equations. So add 3, x is 3, add 1, and x is 1. So my two answers are 3 and 1. My next problem, I don't have it set equal to 0, so I first have to solve and set equal to 0. So I'm going to minus 4x from both sides, and I'll add 1 to both sides. So I end up with 3x squared minus 4x plus 1 equals 0. Factoring the left-hand side, I get a 3x times an x is a 3x squared. 1 times 1 is 1. Check with the smiles. I need a negative 4, so I need a negative 1 and a negative 3. So both of those will be negative. Set each part equal to 0. And solve. Add 1 to both sides. 3x equals 1. Divide by 3, I get 1/3. Add 1 to both sides, x equals 1. Answers are 1/3 and 1. On the next example, you can see that it's already factored and set equal to 0. So I have just the final step of taking the 3x minus 1 and setting equal to 0. Take the 3x plus 1 and set it equal to 0. Add 1 to both sides to solve this equation. Divide by 3. X is 1/3. That's one of my solutions. Subtract 1. 3x equals negative 1. Divide by 3. X is negative 1/3. So my two solutions are 1/3 and negative 1/3. This next example looks a little different. I've got two sets of parentheses. It's just this first one says 2x equals 0, and the second one says 7x minus 1 equals 0. Well, when you divide by 2 on both sides, you just get x is 0, so x equals 0 is one of my solutions. On the second part, I'll add 1 to both sides, and I'll divide by 7, and I get a negative 1/7 as my second solution. I have just a few more examples of using zero product property. So on this particular problem, what I'm going to be doing is, since it's already set equal to 0, I'm just ready to solve by factoring. So I'm going to put 3x times an x, because that's the only thing that will give me 3x squared. I'm going to put my 7 over here and my 1 here, because I get a 1x and a 21x. I'll get a negative 20 by putting a negative with the 21. So I need a negative here and a positive there. 3x plus 1 equals 0, and x minus 7 equals 0 will give me my solutions. Subtract 1 from both sides and divide by 3. X equals negative 1/3 is one of my solutions. My second solution can be found by adding 7 to both sides, and x equals 7. In this problem, I have it set equal to 0 and it's already factored. So I'll take each part, set it equal to 0. I'll subtract 5 from both sides, x equals negative 5. Second part, I'll add 5 to both sides, 6x equals 5. Divide by 6, x equals 5/6 is my answer. 2 more problems. This one, again, is not set equal to 0, so I need to move the 18 over and the 11. So I'll subtract 18x and I'll add 11. 7x squared minus 18x plus 11 equals 0. When I factor, I have 7x and an x. I'll put 11 here and a 1, so that way I get an 11x and a 7x. I need to create a negative 18, so that means both of these need to be negative. 7x minus 11 equals 0, and x minus 1 equals 0. Add 1 to both sides, x equals 1 is one of my solutions. Add 11 to both sides, I get 7x equals 11. Divide by 7, x equals 11/7. That's my second solution. In my last problem, again, it's not set equal to 0, so I need to move everything so that it can set it equal to 0. So I'll subtract a 9x and I'll add a 3. So I have x squared minus 9x plus 3 equals 0. When I try to factor this, it is not factorable. I cannot, in any way, shape, or form, ever get a 9 inside of there. So I'm not going to say this doesn't have any solutions. However, I cannot solve this by factoring, and I have to use another method which we haven't learned yet. So I will just simply write, I cannot solve at this time using the factoring method. Another method will have to be used. We will learn that method another day.